Welcome back. Let's have a look at how we would want to solve this question. That is, how do we create a stack data structure that has peek, push, and pop? Now, peek should be fairly easy, right? We just want to see the very top item on the stack. So I can just say peek is going to return this dot top. That's it, nice and simple. So that if we run my stack.peek, it's going to return null because, well, there's nothing in our stack. This dot top is null. That is empty. Let's go to the interesting one, that is push. How do we add things to the stack? Well, the very first thing we want to do is to create a new node. And like I said, we can create a new object here if we want, or we can just use the node class that I provided for you here. We can use the class by saying new node, which instantiates the class and gives it the value that we're going to push with. Next, we want to check if this is the very first item, because if the stack is empty and this is the very first item, well, top and bottom are both going to point to the same node. So in that case, we can check for if this dot length is equal to 0. In that case, we can just say this dot top is going to equal the new node. And also this dot bottom is going to equal the new node. Otherwise, we have to do something a little bit different. But not that different because we've seen it in the linked list example. We just have to change some pointers around. In our case, we want to say const holding pointer to the very top node, because whatever on top now is going to get replaced by whatever we're going to add to it. So we're going to hold the reference to what was top originally. And then we're going to say that this dot top is now going to equal the new node. And this dot top dot next, which is now the new node, is going to point to what was top beforehand, but now is below it. So we just say holding pointer, so that is the old top, is now going to be right after our new node. And then finally, we do the this dot length plus plus to increment the length by 1. And then finally, we want to return, let's just return this, which will return us the linked list. Let's see if that worked. I'm going to say peek first. Well, there's nothing here. But if I want to push to my stack, I'm going to say push, and we'll push Google first because we're visiting Google first. And if I run this, I get a data structure that has top, that has the node value of Google. Next is null because we only have one item. And the bottom is also the same Google with next null. And our stack has a length of 1. What if we keep adding here? Let's go to Udemy next. If I click run, I now have a length of 2 stack that has top node as Udemy and bottom node as Google. Because remember, with a stack, we stack plates on top. That is, Udemy came in last, so Udemy is on top. Remember LIFO, last in, first out. Let's add one more. Let's say that we next visit our Discord community. So let's say push Discord. And I click run. And there you go. We have our Discord community at the top. At the bottom is node. And just to make sure that our peek is working, if I do peek, we should get Discord because it was the last in and the very top of our stack. Very nice. I hope you got that. Let's continue with pop. That is to remove whatever is on the top of the stack. Well, let's first check to make sure that there is an item, because if there isn't and we just have null, well, we just return null. So in this case, we can just say if this.top, if it doesn't exist, in that case, we'll just return null. Then next, we can just do our const holding pointer to this.top. So what is currently at the top, which is Discord. And we'll say that this.top is no longer what it currently is because we want to remove it. It's going to equal this.top.next, which is underneath Discord. And then finally, we say this.length minus minus because we want to decrease the length by 1. And then finally, we can say return this. Now remember, because JavaScript is a garbage collected language, if I didn't do this and said holding pointer to this.top, well, Discord, this node that contains Discord, wouldn't be referenced by anything and not used by anything, which means in a garbage collected language like JavaScript that it will get automatically removed from memory during garbage collection. So if I run this, well, I haven't done anything yet, but right now for pop, let's just return the holding pointer. If I click run, or let's first do mystack.pop to remove Discord from the list. If I click run, I get back the Discord node, which is the holding pointer, in case we still want to have access to it. Otherwise, if we just want it to disappear and we don't need it anymore, we can just return this. We can even comment out the holding pointer. And if I click run, we now have just Udemy at the top and Google at the bottom. And Discord is disappeared from memory. So let's keep going here. Let's say I want to pop one more. And if I run this, I now only have one thing, the Google, which was original item on the stack. So what we just did was we went to Google, then we went to Udemy, then we went to Discord. And then we popped whatever's on the top, and then we popped Udemy, and now we're just left with Google. If I do one last pop here, and I click run, we have top, which is null, but we have bottom node still having Google because we never removed in the pop our bottom node. All we did was replace the top. So we just need to add one conditional here, which is if this.top equals this.bottom, that means there's only one item on the list. I could have also done this.length equals 0. If both of them are equal, which means there's just one node left, in that case, we want to say that this.bottom is going to equal null. Because after we remove the only node left, we want bottom to equal null. So if I do this and click run, there you go. We're back to our original empty stack. I hope you got that and were able to make sense of it. We have another exciting exercise in the next video. I'll see you in that one.